Assalamualaikum and good afternoon to our lecturer, Dr. Shamsul bin Muhammad. For today, our group, which is group 3, will explain about our experiment, which is about the data of the mean amplitude, data for oil condition for gravel surface. Below are the data that we obtained based on the journal that we studied and observed. That data will be calculated and observed its statistic linear regression. So the result and discussion for this section are based on hand calculation and Excel simulation. So in our experiment, we are required to find the mean, standard deviation, minimum and maximum value for the independent and dependent variables. So as you can see here in table 2, this is our descriptive statistic. So table 2 shows that the independent variable frequency has a mean of 50.5, a standard deviation of 29.01149, a minimum value of 1, and a maximum value of 100 for the independent variable. The frame, which is the dependent variable, has a mean of 0.15544, a standard deviation of 0.1500, a minimum value of 0.023, and a maximum value of 0.721. So for B is to sketch a scatter diagram and regression line for the data. So as we can see here in figure 1, this is our scatter diagram and regression line. So the scatter plot is used to assess the strength of the link between two variables, frequency and frame, while the regression line is used to depict the relationship between the two variables by describing it as a linear function. As a result, the relationship of our regression model is a negative linear association between the frequency and the bicycle frame. So for the next data, I'll pass it on to my partner, Alif.
Okay, for C, which is assuming a linear relationship, to use the least square method. So here in table 3 is the simulation for Excel. And for the manual calculation, you can see below. So for the sum of X, we have obtained 5050. Sum of Y is 15.544. Sum of X squared, we get 338350. Sum of Y squared, we got 4.644, and sum of X times Y is 577.052. And N is the total of our data, which is 100. So based on the formula of the least squared method, we need to find the xy first, and from there we have obtained the value of negative 207.92. Next for the value of sxx, we obtain the value of 83325, and syy we obtain the value of 2.228. So after that, we have to find the regression coefficient, which is the beta 1. So for the formula is sxy divided by sxx, and we have the value of negative 0.0025. For the next one is the y-intercept, which is the beta 0. The formula is y bar minus beta 1 x bar. So we have attained the value of 0.2816. As for the least square line, which is the y equal to beta 0 minus beta 1x. So this is our square line, which is y equal to 0.2816 minus 0.0025x. Which are a piece.
Alright. Okay, for my part, which is we check the signification, which is a equal to 0.05, which is of the simple linear regression in model like in the C. So like from the table you can see is the result from the regression, which is we got and the residual. Okay, which is the total that we got from both of the calculation before is 99. Okay, as you can see from the data above, we have obtained a signification value of 0.0004, which is less than 0.05. Hence, we can say that the simple regression linear model is very significant. Okay, next is we interrupt the meaning of the intercept and slope in this problem. Okay, what we can comment from this impossible event. From the figure 1 and table 2, which is actually from figure 2 and table 3, this is mistaken. We can determine that the intercept that we have obtained is 0.2815, while the slope that we get is negative 0.0025. Thus, it can be said that when the frequency is increased by 1%, the vibration in the frame is decreased by 0.0025%. Okay, next, I will give back to Alip.
So for this one, we have to test the hypothesis for H1 beta 0 is not equal than 0 and H1 beta 1 is not equal to 0 by taking 5% level of significance. So for the hypothesis test for beta 0, which is there are 5 steps to get the solution. So for the step is we have to name the beta, which is 1 H0 beta 0 equal to 0 H1 beta 0 is not equal to 0. So for step 2, which is the right tail test, uh, for alpha we will get for 0.05. N is the number of our data, which is 100, and x bar is the x divided by our data, and s is the standard deviation. So for this one, ZC, when ZC equal to Z 0.05, which is equal to 1.645. And this decision is if Z test is bigger than ZC, we have to reject HO. Now for step 3, we have to calculate the Z test, and from there we obtain the value of 17.400. So step 4, since Z test is bigger than ZC, so we have to reject HO, which is for the decision above. And for step 5, we can conclude that there is enough evidence to support the claim that the constant beta 0 is not equal to 0. Now for the hypothesis test for beta 1. This is firstly we have to name the function, and then step 2 is the same, which is the right tail test. And for step 3, we have to calculate the Z test, and we have the value of 10.36. And since this decision is that if Z test bigger than ZC, so we have to reject HO. So we can conclude that to support the claim that the constant beta 0 is not equal to 0. Now I will pass to my friend Alkia.
So as for the G question, which is we need to compute the coefficient of person correlation and interdependent meaning. So we need to find the person correlation, which is the formula is R equal to SXY over with square root SSX multiply with SYY. So we just substitute the value that we calculated, which 207.92 divided by square root 83,325 multiplied by 2.228, which is equal to negative 0.4826. Then we put the formula into the Excel, and the answer are inside into the Excel, which is negative 0.48256652 in the Excel. So the meaning of the person correlation is a statistical method for determining the degree and direction of a linear relationship between two variables. In this example, the link between frequency and bicycle frame. The individual correlation coefficient be anything between positive 1 to 1. The correlation is either positively or negatively weak linear connection if the value of the correlation is 0 or 0.5. If the correlation coefficient is 0.5 or 1, 0.5 less than R or less than 1, the relationship is either favorably or negatively strong linear. It is a perfect correlation if the correlation value is equal to 1. As a as a result, our correlation value of negative 0.4826 indicates that our correlation has a weakly negative linear connection between frequency and frame. Uh, in figure 2 also, we also use Excel to confirm that our Pearson correlation is correct by using the Pearson formula in Excel. So then we go to H question, which is compute the coefficient and of determination and interpret the meaning. So this is the formula which r r squared equal to bracket SYY minus with SSE and divide by SYY value. So SYY value we already calculated. So the negative SSE, how to find the SSE value? SSE value is equal to SYY minus v beta 1 SXY. So we get the, so we substitute the value 2.228 minus with 1.708 divide by 2.228 and we got 0.233 to 0.2333. Then so the below is the table inside the Excel. So the meaning of the coefficient of determination is used to measure how well the regression line represent the data. This means that coefficient of determination represents the percentage of data that is closest to the line that is best fit for the value of coefficient of determination that we have obtained is 0.2333 and based on the table 3, which is from Excel, we have obtained 0.232870446, which is close to our calculated value. This means that the value of our coefficient is close to 1. Hence, it will have a small relationship between frequency and the frame, where 23% of the total variation in Y frame can be explained by the linear relationship with the X frequency. The other 77% of the total variation in Y frame remain unexplained. So as for the conclusion, we managed to calculate all the value that are required to complete our report. So that's all from us. Thank you very much.